Hello everyone. Let us now discuss how can we solve this problem. Maximize the number of target nodes after connecting trees 1. So there exist two undirected trees with n and m nodes with distinct labels in range 0 to n minus 1 and 0 to m minus 1 respectively. So we are given 2D integer arrays edges 1 and edges 2 of lengths n minus 1 m minus 1. So the number of edges we have are n. So n will be edges 1 dot size plus 1, right? And also m will be edges 2 dot size plus 1 plus 1 plus 1. Now, okay, where edges 1 of I is equal to AI, BI indicates that there is an edge between nodes AI and BI in the first tree, and edges 2 of I is equal to UI, VI. That indicates that there is an edge between nodes UI and VI in the second tree. You are also given an integer k. So we are given with a tree 1 and tree 2 and an integer k. These are just given as edges ai comma bi. That means there is an edge between ai and bi. We have ui and vi, edge between ui and vi. Now node u is the target to node v if the number of edges on the path from u to v is less than or equal to k. Note that a node is always target to itself. So what they are asking is just take this node which is considered as u. Now I have another node x, I have another node y, but the k is given as 3. Y and then z and then another thing like a. Now k is equal to 3. So here the distance till u to u is just 0. Till here it will be 1. Till here it will be 2. And till here it will be 3. So this one, this and this. Totally there are 4 nodes which are called as target nodes. Now let us look at another example so that we can understand what is a target node. So taking u, instead let me take as 1 and then 2, 3, 4, 5, 6 and then 7. Now what if we are given with k is equal to 2? Now I will take this is target to itself, right? And then k is equal to 1. That means distance is 1. It is 0 here. Now it is 2. So the total number of target nodes are totally 1, 2, 3, 4, 5, 6. So there are totally 6 target nodes for node 0. That means we are starting at node 0 and k is equal to 2. So these are the explanation for target nodes. Return an array of n integers answers where answer of I is the maximum possible number of nodes target to node I. So answer I is the target number of target nodes to node I of the first tree. Okay, now that means we need to take every node in the first tree, and return what are the number of target nodes. Okay, what we need to do, uh, what are the number of target nodes? Is it only in tree 1? No. What we need to do is, if you have to connect one node from the first tree to another tree in the another node in the second tree, so we need to connect a node from the first tree to a node in the second tree. I don't know which node to be connected, and we need to connect in a way so that we'll get maximum possible number of nodes target to node I, so that there will be, if I am connecting this node, then I need to get maximum target nodes. Now let us just see that we have tree 1, right? Now what I'll do is just take this tree 1. First thing, take this tree 1, 0, 1, 2, 3 and then 4. Now, if I connect this with node 0 in tree 2, let us see what it will be happening, right? If I connect this to tree 2, then I would get 4, 5, 6 number of tree nodes. Let us check. I am just connecting node 0 with the node 0 of tree 2. Now, I have k is equal to 2 for this example, right? So, for node 0 of tree 1, the number of target nodes, let me check number of target nodes for 0. Instead, let me write it as uh, answer of I, right? Answer of I, that means instead I'll write it as answer of 0. So first thing, this is target to itself, right? Okay, now at a distance of 1 we have 3 nodes. Now 1 plus 3 will be 4. Now at a distance of 2 I have 2 here and then 3 here. So totally 5. 5 plus 4 will be 9. So answer of 0 is equal to 9. Now let us see what if we connect with node 1. Let us see what it will be happening, right? So I am connecting node 0 with node 1 of tree 2, right? So if I do that, I need to remove this edge, right? And then I am taking another edge. So node 0 to node 1. Now let us see what are the answer of let us see. I have 9. I need to change if I got anything other than 9, if I got a greater value than 9. So I'm connecting this 0 to 1. Now let us check. I have at a distance of 0 only node 0, and let us see, 1 is till now target nodes. Now at a distance of 1, 1, 2, 3, right? Just totally 3 at a distance of 1. Now 1 plus 3 will give us 4. Now I have at a distance of 2. I need to take only till distance of 2, right? Which is less than or is equal to k, at a distance of less than or is equal to k. Now at a distance of k, I have at a distance of 2, 1, 2, 3 and then 4. So 4 plus 4 will give us 8, but it is not greater. But if I have to tell something like I need only one node to connect with, right? I just need one node, which is the node that I have to connect, right? Then I will get the answer. Now let me tell you that I need only one node. Let us see how I can get that node, right? Now C at 0 at a distance of only 1, only k minus 1. Why? Why? Because if you connect 2 to 0, this will come at a distance of 1, right? And this second node will come at a distance of 1 again. So totally there will be 2. So imagine if we got k is equal to 3. Then this node will be having at a distance of 1 with tree 2, the node tree 2, the node with tree 2. And then at a distance of 2 here, at a distance of 3 here. So for this node, I need to check what is the k minus, what are the number of target nodes which comes under k minus 1. Why? Why? Because the uh, another element or another 1 unit of distance is covered by connecting from here to here. I think you got it. Now let us see. I got why I am using k minus 1 for tree 2. So what I'll do is just check how many target nodes are there for every node which comes under k minus 1. So for 0, I got 1, 2, 3. I got 3. For 1, let us see. For 0, I got 1, 2, 3. Right? For 0, I got 1, 2, 3. For 1, I got 1, 2. Okay, I got 2. For 2, I got 1, 2, and then no, just 1, 2. 1 and then 2. Right? For node 2, I got 2. For 3, let us check. For 3, I got only one node. I got only one node. For node 4, I got 1, 2, 3. For node 4, I got 3. For node 5, I got one, only one. So for node 5, I got one. For node 6, I got only one again. So for node 6, I got one again. So from maximum or from to get the maximum out of all, I'll get only 3. So max reach, I take it as 3. Now I got the maximum reach with tree 2 is just 3. That means the maximum target nodes that I can get if I have to connect the node from tree 1 to another node in tree 2, then I would get 3. Now let us look at here. This also need to check, right? K is equal to 2. That means I have 4 nodes which are at a distance of K is equal to 2. Less than or is equal to K is equal to K, right? So there are totally 4 nodes. For node 0, I have 4 nodes. This is the most important thing for tree 1, right? For tree 1, the nodes coming under distance of k, right? There are, for node 0 there are 4, but no, there are 5. Why? Because the node which is itself, right, is also considered with a distance of 0. So there are totally 5 nodes. Now I have 1 is counted, 1 and then 2. This is at a distance of 1, and then here another node which is at a distance of 2, 1, 2, 3, right? So here for node 1 I got 3 nodes. Now for node 2 I got 1 node, and then at a distance of 1 I got just 3 nodes. 1 plus 3 is 4, and then I got another node, just 5. So at for 2 node 2 I got I got 5 nodes totally. For 3, let us check. For 3, this is the first node, and at a distance of 1 I got only one node, and at a distance of 2 I got 2 nodes. Totally I got 4 nodes for node 3. Now for node 4 I got this one, and then at a distance of 1 node, and at a distance of 2 I got 2 nodes. So for node 4 I got 4 nodes, right? Just totally if I connect 0 to 0, that means I'll get 3 here, and totally 5 nodes for 0 and 3 plus 1 plus 3. Why? This node hasn't been counted. Now instead of 1 plus 3, we will also count this 0. Now my thing is, how do we implement this BFS? Now we'll do one thing. We need to write a BFS algorithm here and do a dry run there. So in the BFS, what I will take is start with a node. Now I'll be having K and start node and the tree. Here the tree can be tree 1 or tree 2. Start can be any node. K can be K or K minus 1. So in the main algorithm, we'll be calling for taking two vectors, reachable of 1 and reachable of 2. These are the two nodes, right? So what I'll do is, for reachable of 2, let me go for reachable of 2. For int I is equal to 0, I is less than m, I plus plus, I'll call for reachable 2 of I is equal to BFS of what is the starting node, right? So the tree is tree 2, and the starting node is I. And what is k? K is k minus 1, as I said. So I'll be going till k minus 1 for a node in tree 2. So I'm going till k minus 1. Now, as I only need max reach will be maximum of max reach, comma, reachable to of I, reachable to of I, right? Now for int I is equal to 0, I goes to n, and reachable 1, reachable 1 of I is equal to BFS of, here it will be tree 2, right? Here it will be tree 1 comma I comma k. So why? That means I need till k for tree 1, as I went till 2 for tree 1. Now I got tree 1 BFS of tree 1 comma I comma k. Now what I'll do is initializing an answer, and don't forget to initialize max reach is equal to 1. Instead I'll be just taking with 0. Now let us go with the answer. For int I is equal to 0, I is less than, wait a second, I is less than n, I plus plus, answer of I plus is equal to reachable of I plus max reach. So let us see how we'll be getting through the BFS algorithm. So here we have tree, start, and k. Now I'll write the BFS over here is start. Let us see. The first thing I need, I need the number of target nodes. So for that I'll initialize count is equal to 0, and I need a queue for this BFS traversal, and also distance of n comma minus 1. Now what I'll do is just distance of start node is 0, as I said, and the count is not 0. Why? Because this starting node is should be counted. So count is equal to 1. Now I'll push back q dot push this starting node, and what I have to do is this, while q is not empty, what I'll do is just take int node is equal to q dot front, and remove that from the q dot pop, and for auto neighbor, for tree of node I go to every neighbor, and if this distance of neighbor is equal to minus 1, then I have to change it. So then it will be distance of neighbor plus is equal to, oh sorry, distance of neighbor is equal to distance of node plus 1. And if this distance of neighbor is less than or equal to k, then I'll increment the count and then push this into our, so this is how we'll solve this problem, and at the last we'll be returning the count of number of target nodes. Now let us apply the same thing here. So here I'll be calling for reachable 1. It will be having 0, 1, 2, 3, 4, and here I think we are given with k value as just 1, right? So let us just change it and just take k is equal to 2, right? You will be understanding much clearly if I take k as 2. Now for node 0 it will be calling for with let us take a distance here. So distance here, distance vector will be having from 0, 1, 2, 3, 4, and for 0 it will be having a distance of 0. Everything will be minus 1, minus 1, minus 1. And is there anything? No. Here we will be having a q, it is having 0 pushed back. Now 0's numbers are 1, 2, 3, 4. 1 is having a distance of minus 1. what I said, when I have minus 1, then distance of neighbor is equal to distance of node plus 1. So distance of 1 will be distance of node. The node is 0 and the neighbor is 1. So the distance at 0 is 0. 0 plus 1 will be 1. And here it is coming under k, which is less than or equal to k. What I need to do is count till now is just 1. I'm just incrementing, and then what I'm doing is q dot push neighbor. So q dot push, it is popped back, and q dot push 1. Then I have another neighbor 2. So 2 is also done the same thing. 0 plus 1 will be 1, and this isn't popped back. Now count will be incremented as the distance is less than or equal to k, and then this 2 will be pushed back into the queue. Now I got 3. 3 will be having a distance of minus 1, and the node is 0. So if I increment 0 plus 1 will be 1, and then here the count will be incremented. Why? Because this 1 is less than or equal to k. So there are 4 nodes. Now I'll push back this 3, and then I have 4 again. 4 is also the neighbor of 0, and the distance of node is 0. 0 plus 1 will give us 1, and then I have the count as 5, and I'll push back this 4, and I'll get this queue will be popped back 1, and there are any nodes? No. And even if there are nodes, it go to 0, and the here this will be only done if distance of neighbor is equal to 1, is equal to minus 1, but it is not true. So this all 1 2 3 4 will be popped back. That's it. And the distance, oh sorry, the count of 5 will be returned to here, reachable of 1. So 0 will be reachable till 5. Okay, now let us go with the 1. Firstly, let me just take this out. Let me just take wait a second. Let me just take this out, and let me go with the 1. Now I have 1, and what I'll do, I'll just get this tree again. Now I have 1. Let us see. Count is equal to 1, and distance, as I said, 0 1 2 3 4, and only one will be having 1, and remaining will be, sorry, one will be having 0, and remaining will be minus 1. And the neighbor of 1 is just 0, and 0 will be having a distance of 1, and 0 will be popped back, and just 1. So the count will be just 2. So there are only 2 nodes in the range of range of so now this 0, there will be 1, and this will be popped back, and then the neighbor of 1 is 0. So it will go to 0, and it is having a 0 as something like uh, a distance of 0. Now if as it is not is equal to minus 1, then it will be brought back again. So there is only one node which can be reached from at the distance. Now I have pushed this 0. Then 0 has some neighbors. The first neighbor is 1, and it is not equal to minus 1. Distance of 1 is 0, right? Now it is having another node 2, and it is having a distance of minus 1, right? So it will be 0 is started with 1. 0 is started, sorry, the distance at 0 is 1. 1 plus 1 will be 2, right? So first thing, when I got 0, the count will be incremented 2, and then at here it will be 3, and then here 4, and then 5. So totally the count will be 5. So this will be the same for every node in reachable 1 of I. So here it can go till every node, and the same thing for every node, right? Now I need just 1. So reachable of 2. Let us take reachable 2. Now 0 1 2 3. Now k is equal to, now we are just want k is equal to 1. So start with 0, and I have only one node which is connected to 0, which is 1, right? So I can only go till 1, and it is distance of 1, so it will be 1. At a node of 0, I can go here and also here, so 1 will be having 2. Now at a node of 2, we'll be going here and then here, so it will be 2. And for 3, at a node distance of 1, we can only go to 1. So the max reach is 2. Max reach is 2. That means we can connect any node of 0 with any node in tree 1 to node 1 or node 2, then I can get maximum number of target nodes. So if I return 5 plus 2 is 7, 7, 7, 7, 7. That's it. This will be the answer, and I have given the code link in the description. Go and check it. And if you like this video, do share it to your friends and do subscribe to my channel. Thank you.